Hi everybody, welcome to today's video. We've got an exciting topic. Today we are going to build an Agent Inference Server. What you see in front of me is actually one of the examples that we have. It's one of the first examples that we did when we were introducing our agent capability in LLMWare. You see at the top, customer transcript, very representative of a customer support automation process. Customer has an issue. We want to set an agent loose to bring a bunch of different tools to bear to produce an analytical output, very much like the one that we see below, in which it classifies the sentiment, the emotions, the intent, the rating. It extracts some key information like the customer information, produces a summary, and delivers all of this in a really structured analytical Python dictionary report. This is one of the examples that we did. And one of the things we highlighted is pretty cool is that all of this is running 8 different models, 9 different inferences in total, are all running on a local machine. Well, one of the questions that we got from this video was, hey, that's really cool, but what if I want to be able to mix up my deployment model? Perhaps instead of having these agents running locally on my machine, can I put this behind an inference server? And how would I do it? And how would I integrate my client code into it? So that is actually the motivation behind this. And this is what we're actually going to go through in this example. We'll come back to this example and then we'll have some fun with it. We'll kind of toggle back and forth between local execution and inference server execution of it. Now, the example that we're going to walk through is another example, and I'll just blow this up here for a second. And what's in this example script, the Agent API endpoint, it includes both the server-side script, so we're going to show how you deploy that. In this case, we're going to use an AWS server. We're going to deploy it on AWS. And then we'll come back afterwards and we'll look at the client-side code and how you actually then register it to go call the server that you've just created. So to just take a minute and to look at the server-side script, it's actually pretty simple, but there are some important details that are packed into this. So we have a class within LLM where it's an LLMWare inference server. Under the covers, it uses Flask. It has a little bit of model management. It invokes other capabilities of LLMWare, and that is the inference server that we'll be using. But the key configurations, the two that I really want to point to, is in this case, we are going to be running on a Linux server. Oops, let me go back. We are going to be running on a Linux server. And so the home path is going to be a Linux path here. And then we do set up a secret API key. Again, this is really designed for testing, development, for prototyping. It's not for production grade security, but we did include at least a minimal key that does need to be passed back and forth between the client and the server, at least as some way, so that you can provide at least a basic minimal level of validation that only people that are using it on purpose should be the ones that have access to it. So in this case, we're just going to call it demo/test. Certainly, even if you're just using this for demoing, prototyping, or experimenting, we would recommend that you manage this a little more carefully, and certainly you set up a more complex and secret API key, but that API key is part of the configuration of the LLMWare inference server. So this is the extent of the server-side script. All right, let's flip over and I'm going to show you how we set up the server. For those who are familiar with AWS, this is a screen that you've seen many, many times. This is the EC2 instance configuration. We have set up a G5 4x large. It is a standard mid-grade Linux Ubuntu 22 server. It is a standalone EC2 instance. What is special about it is it does have an A10 NVIDIA capability. So we are going to get some benefit of GPU acceleration on this server. All we've done, the only prep we've done is we have cloned the LLMWare repository. We've made sure Python is working. We've made sure that the CUDA drivers are there, but we haven't done anything else on the server. Now, I wanted to point this out for a minute. What you will be using, the key way that you're going to be accessing this is through the public IP4 address, not the private address. And please don't worry showing you these addresses. By the time anybody's seeing this video, the server has long since been decommissioned and gone. So there's no secret actionable information on this, but I thought it was worthwhile just taking a minute to show everyone the configuration. And just remember that 5290, that's the actual public IP address that we're going to need. When Flask actually fires up and we see the IP address, it's going to show this private one. Just don't get confused by that. Come back and take the public IP address, the one that you would use to SSH and to connect into the server. So flipping over, we are SSH'd into the server. I'll try to blow this up if I can. I don't know how much I'll be able to do that. And what we're going to do is we'll just take a quick look. This is, I've created an Agent Inference Server in the home Ubuntu path. Within that Agent Inference Server, I've just cloned from the LLMWare GitHub repository. This is the files that I get. All of the LLMWare is running in that LLMWare source folder. And I have pulled out one of the examples just to put it into this main path, which is this Agent API endpoint. That's the code that we were just looking at on the other machine. And then all we're going to do on the server is we're going to run it. Now, if you wanted to change the secret key, if you wanted to change anything else, you'd go in and you'd modify the script. But otherwise, we're just going to go ahead and run it. And for those who have used Flask Application Server or any other WSGI application server, typically this is what you're going to see. The server is fired up, it is running, and it is now waiting for incoming traffic. As I said, again, don't be fooled. This is the internal address. We're going to go with that 52, which is the public IP address that we would SSH into. On our Linux server now, we have our agent endpoint. It is up and running and waiting for us to do something with it. So coming back now over to this script, now let's look at the client-side process. And the client-side process actually couldn't be easier. Once we create our agent object by instantiating the LLMFX class, all we have to do is copy down that IP address. This is the address that we would SSH into. This is the port that we opened by default, was 8080. And then all we have to do is register that API endpoint with the agent. We do that with the register API endpoint method. We pass in that IP address, we pass in that API key, and then we turn that endpoint on. And then the rest of this code is exactly the same code that we had in that example. It's going to load a bunch of tools, a bunch of models. It's going to go run through a whole series of analyses, and then it's going to prepare that dictionary analysis for us. So what we're going to do, I'm just going to comment out this. Again, this is what we used on the server side. Let's comment it out. And then with that commented out, I'm just going to go ahead and run this. We've inserted our IP address. We've registered that endpoint. So the endpoint is on. And I'm going to try to toggle this. The timing might be off slightly, so bear with me, but I'm going to try to get it so we can see the split screen and we can see what's happening on the server side. At the same time, you can see how it's executing locally. All right, so here we go. And there we are. You can see at the very bottom of the screen, the local execution. And what you see then in the middle of the screen, this is our Linux inference server. Every time a request comes in, it's running that process. You see it producing all of the result then, all of the keys that get passed into it, all of the result. And what we get is just what we expected, which is this really nice dictionary analysis. But now with one line of code, by just registering that API endpoint and turning that endpoint on, we pivoted from local execution, all these models running on our machine, to now running on that endpoint. So now just have a little fun with this. What happens if we turn that endpoint off? Okay, so the code is still running, but now nothing is happening on our inference server. Nothing is coming to the inference server. All those models are being loaded and all the inference is happening locally. Again, you see same output, but this time all of the execution happened on our local machine. Now, to promote code reuse, which is one of our key design criteria in creating this, all you have to do is to create this register of an API endpoint, and it'll toggle the execution from local to inference server. And you can imagine some scenarios where you may want to at times do local execution, at other times you may want to route it to an inference server, or some other hybrid type of topology where you're going back and forth between them. So just to show you another example of how this works, we're just going to copy and paste this key line of code. This is the IP address of our server. That's the registration of that endpoint. Now we're going to go over to another example. This is an example that we actually went through that does some research automation on some of the early days of Microsoft's rivalry with IBM, runs some sentiment analysis, some topic analysis. It goes through a whole complex, agent-based process. And we're going to do the same thing. So here we go. This is where we're creating our agent. Our agent then is going to go through a series of steps. All we're going to do is literally copy and paste. And now we're registering that API endpoint within this agent process. And now let's run it. And there you go. You see our inference server is working. All those inferences are coming to the inference server. It's processing it. and then sending it back to our local execution. You can see it's pretty fast, especially when we take these models and we have them running on a CUDA-enabled GPU-accelerated server. You can see you get really, really fast inference. There's virtually zero latency. It's pretty nice, actually, how fast it's executing through this. It is faster than if this was just running locally on my Mac. Once we're done this way, we'll toggle it again. And so you can see how easy it is to go back and forth from that local execution mode to running it through the inference server. So we are almost done. All right, there we go. So it completed all of this work. It did a bunch of research on a Bill Gates biography, analyzed and gathered a report of key moments where there was negative sentiment in the rivalry between IBM and Microsoft in the 1980s around the launch of OS/2 and Windows, all that critical moment in kind of the history of the software business. All of that analysis was gathered all using our API endpoint. And now again, we could simply, to turn this off, we could comment this out, or we could use the specific method, which is switch the endpoint off, and our execution is going to pivot back to local execution. So we hope this has given you some new ideas, some exciting directions around how you can start easily standing up your own inference server so that you can start running these complex processes, having an inference server, and then running code locally. Check out the example in the LLMWare repository. And please, while you're there, we've got a whole bunch of other new, really cool examples, so go check them out. And as always, any questions, any issues, you want to talk anytime, please come join us on Discord. Thank you, everybody. Take care and enjoy having your own agent endpoint server. Thanks, everyone.